This is OPOSSUM, an open platform for orbital space servicing and uplink near the Moon. In recent years, there has been a growing demand in the industry for conducting science in cislunar space. OPOSSUM was designed by engineers at the Georgia Institute of Technology to meet this demand by providing customer satellites with the power, communications, and station keeping required to complete their missions. Additionally, OPOSSUM will serve as a communications relay between the Moon and Earth for both satellites in the area and a future base on the lunar surface, and the platform will provide space domain awareness for U.S. agencies. Finally, OPOSSUM will aid in NASA outreach endeavors by providing a live video feed of the lunar surface.
Utilizing OPOSSUM services will allow customers to save critical time, mass, and money for their missions. For a typical 100 kilogram satellite, savings can be as high as 13.5 kilograms, $1.2 million, and 18 months of development time. These savings are significant for a minimally funded project, such as a CubeSat for a university. With these reductions, cislunar space will be more accessible to a larger number of companies and institutions. NASA has identified several unique fields of science that can be researched from our position at Earth Moon Lagrange Point 1. Some of these include heliophysics, astrophysics, exoplanet discovery, and material science. While these fields can be studied from a variety of locations, L1 provides a unique environment that can lead to new groundbreaking discoveries. OPOSSUM will also provide space domain awareness, which is the detection, tracking, and identification of debris and other near-Earth objects. This is beneficial for the defense sector by identifying potential hazards headed toward the Earth and satellites in orbit. The U.S. Space Force will be a primary partner for this service.
OPOSSUM will launch from Cape Canaveral on board a SpaceX Falcon Heavy rocket in late 2028. After a one-year flight on a lunar trajectory, OPOSSUM will use its thrusters to insert itself into a southern halo orbit at EML-1. The platform will operate from this location for at least 10 years, after which it will retire into a geocentric graveyard orbit. Seen here in its stowed configuration, OPOSSUM was designed to fit within a Falcon Heavy payload fairing. It will launch with a pseudo-rideshare transport attached to the top. This transport will take the first round of customer satellites to be serviced with us to lunar space.
The platform uses 17 hydrazine thrusters to maintain its orbital position in L1 space, along with a reaction wheel-based attitude control system to reorient the platform as needed. OPOSSUM will be powered by two longitudinally gimbaled solar arrays, along with two backup batteries for operating in eclipse. Two phased array antennas will provide communications for customers and relay information between the Moon and Earth. The platform can service up to 12 satellites at once, including 8 CubeSats of 6U or 12U size and 4 smallsats. Customer satellites will arrive at L1 space on board a rideshare vehicle. Our robotic arm will then berth each satellite onto one of our universal docking adapters. While docked, the customers will be provided with power, communications, and station keeping for the duration of their stay. OPOSSUM is adaptable to each satellite's own disposal plan after their mission has concluded.
Much like the opossum, an animal native to North America that carries its young on its back, our platform will provide critical needs to small satellites that wish to operate with us in cislunar space. With these services, OPOSSUM will be a critical step in developing sustainable, permanent infrastructure in cislunar space.